Today we're going to be looking at determinants of transpose and inverse of matrices, and we're going to do two JEE Main questions. This one here is the first one, and the second one is just here. They're very similar questions, and even though they look very complicated, in actual fact they're pretty easy once you get your head around a certain number of relatively simple rules. So let's just go through the rules first. Here are the rules. Let's put them here. Okay, these are the must-know. Now, you don't even need to know what a determinant is in order to answer these questions. That's what makes them so nice. So, rule number one, we got a determinant properties related to a square matrix A, B, and C with n rows and columns. Okay, so the determinant of ABC is equal to the determinant of A times the determinant of B times determinant of C, and that's another way of writing it. Just writing it like that is the same as writing determinant. The second one, the determinant of the transpose of A is the same as the determinant of A. Again, it's written like that. The third one is the determinant of the inverse of A is equal to 1 over the determinant of A, which is written like that. The fourth one is when we multiply a matrix A by K, it multiplies its determinant by k to the power of n, where n is the number of rows and columns of the matrix. And the fifth one, which we're going to deal with in another video, the determinant of the adjoint of A is equal to the determinant of A to the power of n minus 1. These questions, which we're going to do in another video, are hard. But they're good fun. So what we're going to do in this one, we're just going to look at these. Now, just a matter of interest, if we look at number 3, because it's always easier to understand these things if you know where they come from. If we look at A times A minus 1 equals I, the identity matrix, that's the definition of an inverse, then of course the determinant of A minus 1 equals the determinant of the identity matrix. Well, the determinant of the identity matrix is 1, and so therefore determinant of A minus 1, and from rule number 1 we can write that as determinant of A minus 1 equals 1, and if the determinant of A is K, then the determinant of A minus 1 is clearly 1 over K, and that's where the third rule comes from. The fourth rule basically is when we multiply a matrix by K, we multiply every single element in all the rows and columns by K, and a determinant, when you multiply one row or column by K, it increases the determinant by K, so multiplying the entire matrix by K will multiply all of the columns, and there are n rows or columns, and that's why for 4 the determinant of K times A is equal to the determinant of A times K to the n. Anyway, that's just for a bit of background. Going back to the questions, you'll see how easy they are. Right, so let's go to the first one now, knowing our rules. So A and B are two invertible matrices of order 3 by 3. Okay, so they're square matrices, and we know that therefore n equals 3. If the determinant of AB, A transpose is 8, and determinant of A times the inverse of B is 8, then what is the determinant of that? Okay, so let's make let the determinant of A equal A, and let's let the determinant of B equal B, so easy so far. So we know by our rule that the determinant of A transpose is also A, because we know the determinant of the transpose is the same, and therefore the determinant of B transpose is B. And we know that the determinant of A to the minus 1, the inverse matrix, is 1 over A, and likewise the determinant of B to the minus 1 is 1 over B. Now all we need to do now when we look at this determinant A, B, T, well, we know that equals the determinant of A times the determinant of B times the determinant of A transpose. We worked that out in rule 1 below. So we know that therefore 8 equals A, B, A, which is A squared B. And then from this second one here, AB minus 1 is 8. We therefore know that because we know that the determinant of AB minus 1 is equal to the determinant of A times the determinant of B minus 1, which equals A over B, and we know that is 8, we're given that. So now all we have here is two very simple equations, and solving those, I won't bother going through why we solve them. Basically we get that A cubed is 64, i.e. A equals 4, and therefore B equals a half. And so therefore looking here, the determinant of B, A to the minus 1, B transpose, well, that is equal to B times 1 over A times b, just for our basic rules, which is b squared over a, and simply plonking in these values here gives us, that is 1 over 4 times 2 squared, which is 1/16, which is answer 3. You're not going to get much easier question than that once you understand the relationship between the determinant of the matrix, the determinant of its transpose, and the determinant of its inverse. Okay, so that's number 1. Number 2 is pretty much the same. Let's have a quick look at it. Just pause the video if anybody wants to do it. Now this one you do at least need to be able to work out the determinant, but the determinant of a 2 by 2 matrix is equal to that times that, take away that times that. So the determinant of A equals root 2 squared minus 1 times 1, which equals 3. And the determinant of B is 1 times 1 take away 0 is 1. Okay, so basically we know that C equals A, B, A, T. So therefore the determinant of C is the determinant of A times the determinant of B times the determinant of A transpose, which equals 3 times 1 times 3, which is 9. And therefore looking at X here, and in actual fact we don't even need to bother with all of these steps, but I will do it anyway. So X equals A transpose C squared A, which is the same as A transpose C times A. So the determinant of X is the determinant of A transpose times the determinant of C times the determinant of C times the determinant of A, and that equals determinant of A transpose is the same as determinant of A, determinant of C, determinant of C, determinant of A, and that lot equals 729, which is answer number 2. So you can see, once you have got to grips with these 4 rules here, answering these types of questions is actually quite simple. That's not the case with this one, number 5, which we will do in the next video. Even though this is a simple formula, answering those questions is not at all simple. You really need to have your brain switched on, so look forward to that. Okay, well, anyone who's found this useful, please like this video by pressing the little thumbs up button and subscribe to the Cresty Academy YouTube channel. Thank you.